Greetings, M Squared here. Today we're going to talk about solving quadratic equations by graphing. So there's 5 ways to solve quadratic equations. We're going to focus just on the graphing today. But know that in the next few weeks we will do all 5 of these. So solving an equation is the same thing as finding the x-intercepts. That is a super important concept to understand. When we're asked to solve an equation, if we were to graph it and just find where the x-intercepts are, those points are the answers to the solutions. So there's different words we use. Sometimes we use the word solve. Sometimes we use the word find the x-intercepts instead of solve. And sometimes we use the word roots. And sometimes we use the word zeros. So all of those really mean the same thing. So if you're ever asked on a question, hey, find the x-intercepts, or find the zeros, or find the roots, or find the solution to an equation, those all mean the same thing. So when we're solving an equation, if it means find the x-intercepts, then the best way to do it with graphing is to graph that guy and then find out what the x-intercepts are. So these are our solutions. Negative 4, 0 is one solution, because that's the x-intercept on this side. And 4, 0 is another solution. So a parabola can have up to 2 solutions. But it doesn't have to have 2 solutions. So this little chart right here kind of shows you how if I don't have any x-intercepts, that's considered a no solution. And it can look like that picture right there. It could also be reflected over the x-axis. It could be down there too. But it never crosses the x-axis. Then I could have one solution. And that's where the vertex is actually on the x-axis, and it either goes up or down. So it's just that one solution. And then it could actually cross twice, and then I would have 2 solutions. So those are the options. So when you graph, you're going to have one of those 3 options. So the steps to graphing, to solving by graphing, is we first have to graph, obviously. Then we have to find the x-intercepts, and we just write them as ordered pairs. So if you remember how to graph these things, this is going to be super easy. If you don't, then you're going to have to learn that at the same time. And I don't use tables for graphing. I use the pattern that we've established. So these first 3 are graphed for us, so we don't have to do that step. The next 2, we're going to do that step. So this one, what are the solutions? That just means what are the x-intercepts? So I can see they cross right here at -5 and at -1. So I would write them as ordered pairs. So my solutions would be -5, 0 and -1, 0. Those are the solutions to that. Now, what are the zeros? Remember, zeros means the same thing. This one just happens to have 1 0, right? So that right there is the answer. The reason we call them zeros is because all along this x-axis, the equation for it is y equals 0. It's not the y-axis, that's up here. That guy's x equals 0. But it means that every point along here is y equals 0. That's why you'll see like 0 equals when you're asked to solve instead of y equals, because you're actually finding when y is 0 what the answers are. So you might notice that. So that's why we call them zeros. This one's asking for the x-intercepts. Here's the x-axis. This parabola never crosses the x-axis. So that means there aren't any zeros or x-intercepts. So I would say there are no x-intercepts. Okay, now we're going to go and graph 2. So I'll zoom in a little bit. So we are going to graph this right here. This is a quadratic function. I can tell that by the little 2 there. It's in vertex form. I can tell that by the parentheses. So in vertex form, we have our vertex just staring at us. The opposite of this, that was our h, and then k is right there. So our vertex is 5, 8. So the first thing I do when I'm graphing something in vertex form is graph the vertex. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Then I notice that A is -2. The negative tells me it's going down, and the 2 tells me what pattern to use. Remember, the up 1, over 1, then we have 3 and 5. So we go, our pattern was 1, 3, 5. That means I go over 1, down 1, over 1, down 3, over 1, down 5. But that's for A equals 1. But now A equals 2. So I am going to go down each one. I'm not going to put the negatives, but I would multiply each of those by 2 to find my pattern for the 2, in case you don't remember that. So that's a 2, 6, and a 10. So that means I go over 1, down 2, instead of down our normal 1, over 1 more, and down 6 more, and I just found the x-intercept, so I don't need to worry about, I mean, you can go down to 10, right, as it's there, but you don't have to. because your goal is to find the x-intercepts to solve by graphing. So it looks like they're at 1, 2, 3, 4, 5, 6, 7. So my answers are the x-intercepts. That's the 1, 3, the 3, 0, and the 7, 0. So these are the solutions because that's where the graph crossed the x-axis. So we graph it, then we write down our x-intercepts. Okay, this one is not in vertex form. It's in standard form. Notice there's no parentheses. So the first thing I do when it's in standard form is find my axis of symmetry because this negative b over 2a is the vertex x-coordinate. And then we plug it back into the x values, find f of that to find our y value. So remember, a is the number in front of x squared. That's my 1/3. b is the number in front of x. That's -2. There is no number without a variable, so c is 0. So I'm going to find x equals -b, which is a -2, over 2 times 1/3. Well, those cancel because two negatives, when they're right next to each other, are going to make a positive. The opposite of -2 is +2. The 2's cancel. I'm left with 1 over 1/3, and when I divide, I do 1 times the reciprocal of that, so I end up getting 3. And if you don't know that, you could always use your calculator. That's me not using a calculator. So now I have to find f of 3, because f of 3, excuse me, is the y-coordinate of my vertex. And I always want to graph my vertex first. So here we go, f of 3. Well, f of 3 means I put a 3 in there. So I get 1/3 times 9, because that's what 3 squared is, minus 2 times 3. So 1/3 of 9 is 3, minus 6, that's -3. And I think I moved that line down a little too far, so we're just going to make our new y-axis. It's not supposed to go that far. That was an accident. Okay, so we're going to go over 3, down 3. So we'll ignore this one. Over 3, down 3, and then we're going to use our pattern. Since it's 1/3, my 1, 3, 5 pattern becomes, I'm going to multiply each of them by a third. So I get 1/3, 3/3, which is 1, and 5/3. So this is where it might take a little more zooming in. So here's what's going to happen. I'm going to go over 1, but instead of going up 1, I'm going to go up just a third, because that's my pattern. Then I'm going to go over 1 and up 3/3, which is 1, which takes me up right there, because I'm already at 1/3, so then I go 2/3, 3/3, and then another 1/3. And then I have to go up 5/3, so I'm going up 1, 2, 3, 4, 5/3. So it puts me right there on the x-axis where I need to be to find my x-intercepts. So it looks like a 0, 0, and 1, 2, 3, 4, 5, 6, 0 are my solutions, or x-intercepts. So sometimes they don't cross at nice, pretty integers. You know, it might cross between 6 and 7. And then usually we don't use graphing for that unless we have a graphing calculator and a way to actually find those exact roots. But sometimes there aren't exact roots. Sometimes it's an irrational number going on. But for our beginning purposes, we're going to try to give you those solutions, or ask you what two numbers would it be between, or ask you to estimate it. The other 3 ways of solving quadratic equations, remember we talked about there's 5 ways. There's 5 ways. So these ones right here can have irrational answers. So answers of decimals that don't end and never repeat. But these are pretty hard to solve that way. So we usually reserve these solvings for either an estimate or exact little pretty integers, or fractions that don't repeat forever and never have a pattern. Alrighty, well, good luck. Remember, solving just means find the x-intercepts. M squared signing out.